Rich Prill. I'm with Washington State University Cooperative Extension, and school indoor air is one of my jobs. It's my favorite job. The reason I like it is because it's voluntary. And since it's voluntary, I get to work with people that want to do the right thing. Not because they have to, because they want to. So that's what makes it a favorite part of my work. The walkthrough is not a science project. It's basically, it's just a practical hands-on look at the building, top to bottom, inside and out, just looking for the usual things. Again, a pro tip, something we like to repeat oftentimes is we're just looking for the usual things. It's not a science project. We're not looking for the weird stuff. We just want to look for whatever's typical in your building, see if we can tune it up a little bit. These are our 5 benchmarks. Without benchmarks, you really don't know what your challenges are. So we look for these 5 basic benchmarks, and we look at these through observations and some measurements. So we look for a building that's dry, clean, comfortable. We control the pollutants so they're not getting loose in the building and affecting people. And we make sure the building breathes. We get adequate ventilation for the people and for the any contaminants that might be in that building. We only measure what we can interpret. Science allows us to do a lot of measurements, a lot of high-tech stuff, but we don't know how to interpret that. You get a bunch of numbers, you get a bunch of data, and it's like, well, we don't know what this means. We don't do that. We don't go to a science project. We measure practical, everyday things that we can take charge of. The common measurements we make are moisture, temperature, carbon dioxide, ventilation. So you can see that what happens is we look for a dry building with our moisture meters. We look for comfort with temperature meters. So we measure things that we can interpret. We look for airflow direction. We have some chemical smoke tubes or some pressure gauges to make sure air is moving in the right direction and not contributing to a problem. We look for temperatures, and that costs about $100 for a good temperature meter. Moisture meters are around $300. Carbon dioxide meters start at about $500, and that's a pretty good little package. For about $1,000, you can get some measurement equipment that'll make sense to you. You can use it in your building to look for those 5 basic benchmarks. What gets measured gets fixed or controlled. If you don't know, you don't know. So we like to do some basic measurements. It gives you a baseline like Dave mentioned. You can compare yesterday to today to tomorrow and set some benchmarks or some targets for some improvements. We try and establish as much trust as we can with the people on site, and we're not there to find fault with anybody's job or to make someone look bad in the eyes of the principal or the superintendent or their supervisor. We're just there to find out what's going on, listen to people. The head custodian or the facilities manager or the maintenance person is going to have a lot of insights that we need to share with them. So we ask a lot of questions and try and pat them on the back for all the good things that they're doing. Obviously, they're doing a lot of good things, and we want to be positive if we can. We want to point out any potential problems. If we find something that doesn't look quite right, we're certainly going to mention it, but we're not going to overreact or get people all stressed out. Again, school indoor air is a work in progress. So all buildings have some sort of a challenge. We just want to make sure we don't have huge risks going on. So another thing we like to repeat, it's not a problem unless it's a problem. So we don't freak out over things that maybe some of the guidance you might read says, oh, don't do this. It's like, well, if it's not causing a problem, we'll deal with it later. Let's work on things that are causing people a real issue. We have a walkthrough checklist, or we suggest you have a checklist that doesn't say good and bad. It says okay, or see the notes. And we just make up some notes about what we observe, what we measure, and those are your challenges. It's not good or bad or ugly. It's just what we find. We like to start with a good basic floor plan so we can wander around the building and be organized about it, so we can make notes about what we see in certain areas, or we can go back if we want to check something again. So it gives us an idea to get grounded in the facility and check things out. We make notes of where the pollutants might be located. Art rooms, science class, custodial closet, basements, cellars, boiler rooms, wherever there's gas appliances, natural gas appliances. So we make a note of this on the floor plan because we want that air to stay in those rooms or be exhausted out and not get loose in the building and affect some people. So another one of our mantras is air should go from clean to dirty. We want to control that air. And so we look at airflow through our building, clean to dirty to dirtiest, out of the building. Get it out of there. Typical school here with different usage areas. You can see air should go from the classroom to the shops, library to the chemistry class, not the other way around. You don't know until you look. We use our pressure gauge or a tracer smoke to make sure air's going the right direction. This is some tracer smoke in action, looking for pressure differentials. We want to control pollutants with these pressures. So if you've got a science class with some kids that don't necessarily follow directions, we want to make sure if something goes awry, that pollutant doesn't get loose in the building and cause some people some grief. We're walking down a hallway in this example. We see asbestos behind this door. Guess which way the air is going? Well, on this particular day, it was coming out into the hallway. Probably not something you'd want to advertise. So if you don't check, you don't know. We like to draw arrows on our floor plan to show which way the air is going while we're visiting or during a routine checkup. Then you can go back and turn some of these arrows around that are going the wrong way, or at least put it in your plan. And if you do have a problem in the future, you can go back to your dated plan and say, well, boy, before we had a problem, air was going this way. Now we're having an issue. Let's see if those arrows have turned around, and it may be that simple to correct things. We want to have adequate ventilation, another one of our benchmarks. And we specify ventilation in CFM per person of fresh air. That's cubic foot per minute. We don't look at air changes an hour. We don't look at percent outside air. We like to see cubic foot per minute of air for each person. What that might look like are blocks of air, fresh air, for every person every minute. That's the target. Now, it's kind of hard to tell whether the air is fresh or not that's coming out of a supply diffuser or a unit ventilator, out of the ceiling. How much of that's fresh and how much is recirculated. So we use carbon dioxide meters, which again are $500 or so for an inexpensive one. And it's basically a fresh air machine. If carbon dioxide is building up because of people breathing, you're not getting enough fresh air to carry that carbon dioxide away. That room is not breathing. So the other thing to remember is if CO2 builds up, so does everything else. The marking pens, the body odors, the perfumes, the personal care products, the cleaning products. So we need to have those buildings breathe. And carbon dioxide is just a handy way to make sure that that's happening. So another thing about carbon dioxide, it gives you a number that you can interpret. People like these numbers. As you go around to school measuring on a routine basis your CO2, people see immediately that their room is breathing. Sure gives you a lot of credibility and gives them confidence that someone's paying attention. Whatever's being generated is being flushed out. So people love the numbers, and it's something we can interpret. What we're looking for with carbon dioxide is a number between 800 and 1,000 is kind of our target. If it's a nice mild day, let's get closer to outside, but you can see is about 400. You can't get much below 400. That's our fresh air concentration. So the closer we get to 400, the more fresh air. But certainly in the dead of winter or on a real hot spell, depending on what part of the state you're in, you may not want to overventilate because of energy concerns. So we want to sort of hit that sweet spot of 800 to 1,000. Tells us we're getting adequate ventilation without overventilating a space. These are some sixth graders that were held back because we know CO2 affects performance. When CO2 is elevated, you have a hard time staying awake, staying on task, concentrating. And we've also found a correlation with attendance. We like to note different zones for our air handling equipment. So we can check those zones to make sure that they seem to be working right We find high CO2 in one area, it's probably going to be high in some of the other areas as well because it's on the same piece of equipment.